So far, we have applied all the required settings. In this part, we will initialize the case. Then we can start the solution. I will click on the volume fraction scene. If I click this green flag for initialization, the initialization is performed immediately. As you can see, I now have a very sharp interface. Now let us check one important detail. In the background region, the interface is very sharp. But as it comes close to the overset mesh, it starts to change slightly. To understand that better, let me zoom into this area. Go to the volume fraction scene and click the scalar. There is an option called Display Mesh. If you enable it, you can see the background mesh here. The cells are arranged very cleanly at this interface. So the interface stays sharp at the cell boundary. But when we move from the background into the overset, interpolation begins to happen. So this sharp interface is distributed across the cells. In that case, the volume fraction is no longer exactly 1. And as we move farther, that effect becomes clearer. So cell quality directly affects interface capture. This is one of the key topics in multi-phase simulation. It is especially important when dealing with interfaces. That is why this refinement is important. Remember, we defined a region called water surface. The purpose was to refine the mesh in this zone. You can even see that path clearly in the initialized field. In real cases, when result quality matters, use a finer mesh. At this stage, nothing else is left in the example. Just click Run and let the solution continue. As the simulation advances, the background stays fixed. The interface remains sharp here, while the overset mesh changes. At each time step, the motion is interpolated across the overlap. And you can clearly see the lifeboat descend here. Let me zoom in a little more. So you can see how it enters the water. As you can see, the solution has now finished. One more point is worth mentioning here. This example is different from standard rigid body motion cases. Let me briefly explain that difference. At the end, as you can see, the lifeboat has settled. That is one key difference from rigid body motion examples. In many cases, we prescribe the body motion over all time. But in a case like this, we have fluid-solid interaction. We only provide the initial conditions, such as free fall. After that, the body position is determined by the fluid interaction. And now you can see that it has reached a stable state. We can also inspect the residuals here. Some of them are still relatively high. That mainly comes from the mesh quality. Especially in this region, the cells are still too coarse. You can clearly see the effect on interface capture. The influence of the cell size is obvious here. This example is also based on an official STAR-CCM Plus tutorial. And we reached the main goal we had for it. The idea was to follow the tutorial step by step. That way, we learned how to apply the initial settings. And as you can see, the final result is very similar. Let's quickly summarize what we covered in this example. We explored how the overset mesh works in practice, enabled DFBI to model the lifeboat's freefall motion, and created waves for the initial and boundary conditions. This example is part of a bigger learning path, so continue to the next chapter to deepen your understanding and develop a stronger practical workflow for real CFD simulations.